Welcome back, deep divers. Today we're diving headfirst into a topic that's both fascinating and a little bit mind-boggling.
I know, right?
The golden ratio.
It's one of those concepts that sounds really complex at first,
Yeah,
but once you start to understand it, you start seeing it everywhere.
it's like a secret code,
Yeah,
hidden in plain sight.
exactly. And the more you learn about it, the more you realize just how deep this rabbit hole goes.
So, for our listeners who might be hearing about this for the first time,
Sure.
can we start with the basics? What exactly is the golden ratio?
Okay, so in the simplest terms, the golden ratio is about 1.618.
Okay.
And it comes from this idea of dividing a line into two parts
Okay.
in a very specific way.
I'm listening.
So the longer part divided by the shorter part
Mm-hmm.
is equal to the whole length divided by the longer part.
Whoa, okay, that's a bit of a mouthful.
It is, but stick with me.
Okay.
It's actually simpler than it sounds.
All right, and this ratio, this 1.618,
Yes,
has a special name, right?
it does. It's often represented by the Greek letter phi.
Phi like phi.
Exactly.
Okay, so we've got this ratio, this phi,
Mm.
and it's all about proportions, right?
Yes, exactly.
But why is it so special? Why is it so special? Why do we care about this particular ratio?
That's the million-dollar question. And to be honest, we don't have all the answers.
Oh, come on. You're the expert.
I know.
Spill the beads.
Well, what we do know is that this golden ratio
Yeah.
seems to be linked to this really cool mathematical sequence called the Fibonacci sequence.
Oh, yeah. I remember that from somewhere.
Everyone does. It's one of those things that sticks with you.
Yeah, it's like 0, 1, 1, 2, 3, 5, 8. Each number is the sum of the two before it.
You got it. And here's where it gets really interesting.
Okay.
As you go further down the Fibonacci sequence,
Mm-hmm.
the ratio between consecutive numbers, like 8 divided by 5 or 13 divided by 8,
Yeah.
starts to get closer and closer to, guess what?
Because of the
You got it,
golden
ratio.
No way. So it's like this hidden connection.
It really is. It's like the Fibonacci sequence is nature's way of expressing this golden ratio.
Okay. I think I'm starting to get it.
Good. Because now we're ready to see how this plays out in the real world.
The real world, you mean it's not just some abstract mathematical idea?
Oh, no. This is where it gets really exciting.
Okay, I'm intrigued.
Have you ever looked closely at a sunflower?
Yeah, sure, who hasn't? They're pretty cheerful.
They are. Now, have you ever noticed the spiral pattern on the seed head?
Yeah, it's kind of hypnotic, isn't it?
It is. And here's the kicker. If you count those spirals,
Count them.
yeah, you'll often find they correspond to Fibonacci numbers.
Seriously, like 21 spirals in one direction, 34 in the other.
Exactly, or 34 and 55, or 55 and 89.
And if you divide those numbers...
You get a value that's super close to the golden ratio.
So it's not just a random pattern, there's actual math behind it.
There is. And this arrangement isn't just for looks. It's
Uh-huh.
incredibly efficient. It allows the sunflower to pack in as many seeds as possible.
Oh, I see, so it's about survival.
Survival of the fittest, and the golden ratio seems to be a winning strategy.
Wow, so we've got sunflowers,
Mm-hmm.
Fibonacci numbers,
Yep.
and the golden ratio all connected.
All working together in this beautiful mathematical dance.
I'm already starting to see the world differently.
That's just the beginning.
Wait, hold on. Before we go any further,
Sure.
I have to ask about nautilus shells.
Yes, the classic example.
Right, everyone says they're like perfect golden ratio examples.
Well, that's actually a bit of a misconception.
Oh, really?
Yeah, while nautilus shells are stunning,
Mm-hmm.
and they do have that spiral shape,
Yeah.
it's not actually a golden spiral.
What? So it's not connected to the golden ratio?
Not directly, no.
Okay, so what kind of spiral is it then?
It's called a logarithmic spiral.
Logarithmic. Sounds complicated.
It is a bit more complex, but it still creates that beautiful, continuous curve.
Oh, I see. So it's still about spirals, but the proportions are different.
Ex-
Okay, so even when it's not a perfect match, there's still this idea of spirals being important, fundamental to how things grow.
You're getting it. And that brings us to another fascinating example. Honeybees.
Wait, bees? What do bees have to do with math?
Oh, more than you might think. Did you know their family trees actually reflect the Fibonacci sequence?
Bees and family trees.
Yeah.
I'm officially lost.
Okay, let me explain.
Please do.
So, remember how honeybees inherit their DNA?
Vaguely.
Female worker bees get half from their mother,
The queen.
right, the queen, and half from their father.
Okay.
Male drones, though, they're a bit different.
How so?
They get all their DNA from the queen.
Oh, interesting.
Now imagine you're tracing back a male bee's ancestry.
Okay, going back in time.
Exactly. He has one parent, the queen.
Right.
Then he has 2 grandparents.
The queen's parents.
Yep, and then 3 great-grandparents.
Hold on, 3. How does that work?
Because you have the queen's parents, plus the queen's father's mother.
Oh, I see. 1, 2, 3.
Do you see where I'm going with this?
Wait a minute. It's the Fibonacci sequence.
Bingo! You got it.
So as you go further back in the bee's family tree,
the number of ancestors in each generation follows that Fibonacci pattern.
and the ratio between those numbers
Gets closer and closer to
the golden ratio.
It's like this mathematical principle is woven into the very fabric of their existence.
This is incredible. Sunflowers, pine cones, flowers, bee families. It's all connected.
And we're just getting started.
I can't wait to see what other wonders this golden ratio has in store for us.
Me too. From tiny bees to giant galaxies.
Yeah, it's mind-blowing.
The golden ratio just keeps popping up.
It really does. But we're not done yet, are we?
Not even close. In fact,
Okay, hit me.
we're about to get a little closer to home.
Closer to home. You mean like our own bodies?
You got it.
Wait, are you telling me there's math behind human beauty?
Well, beauty is subjective, of course.
Yeah, of course.
But there's definitely a connection between facial proportions and the golden ratio.
I knew it. I've always wondered why some faces just seem more...
Pleasing to the eye.
Yeah. Is it all about phi?
Well, think about it this way.
Okay.
The ratio of your face width to its height,
Okay.
or the distance between your eyes to the width of your nose, these measurements can often approximate the golden ratio in people considered beautiful.
So maybe those ancient Greek sculptures,
Yeah, yes, the classics.
they were onto something with their ideas of perfect proportions.
It's possible. And it's not just our faces.
Where are
Our hands and arms.
Wait, you're saying my hand is somehow mathematically related to a sunflower?
I know it sounds crazy, but the ratio of your forearm to your hand,
Okay.
or the length of each section of your fingers.
Like from the tip to the knuckle.
Exactly. These can sometimes align with the golden ratio.
Seriously?
Yeah.
So I could be walking around with golden proportions and not even know it.
You very well could be.
Okay, but let's be real. Not everyone's going to have perfect measurements.
Of course not. Human bodies are diverse and beautiful in all their forms.
Yeah, I'm glad you said that.
But the fact that this ratio keeps popping up, even approximately,
It makes you think.
it does, doesn't it? It's
Yeah.
like a recurring theme in nature's design.
Maybe the golden ratio is less like a rule and more like a guideline.
That's a great way to put it.
Like nature saying, hey, this ratio works pretty well, give it a try.
And speaking of recurring themes, let's not forget about our DNA.
Oh, right. You mentioned that earlier.
The molecule itself.
Yeah.
Its dimensions are connected to the Fibonacci sequence.
Seriously. So the blueprint of life itself
Is based on this mathematical sequence.
That's wild. So we've got sunflowers, bee families, our own bodies.
all linked by this one incredible ratio.
It's like a universal language.
What's your code?
Okay, speaking of codes and blueprints,
I see where you're going with this.
we haven't even talked about how humans intentionally use the golden ratio.
You're right. Let's move from the natural world to the world of art and architecture.
Because humans have been fascinated by this ratio for centuries, right?
Absolutely. They saw it as a key to creating beauty and harmony in their work.
Like the pyramids. Weren't they built using the golden ratio?
That's a common belief, but the evidence is debated.
Oh,
There's more solid proof that it was used during the Renaissance.
makes sense. All those beautiful paintings and buildings.
Think of Leonardo da Vinci.
Oh, yeah. He was obsessed with proportions and anatomy.
He was, and he often used the golden ratio in his work.
Like the Vitruvian Man. That's one of my favorites.
Exactly. And it's believed he used it in paintings like The Last Supper as well.
To create that perfect sense of balance.
Yes.
And harmony.
It's amazing to think about, math and art coming together like that.
It's proof that math isn't just about equations, it's a language of beauty.
And not just beauty in nature, but beauty that we can create ourselves.
Exactly. It's like we're hardwired to appreciate this harmony.
And then we try to recreate it in our own art and architecture.
It's a beautiful cycle, isn't it? It is. It makes you wonder if there's a deeper connection there.
Like we're subconsciously recognizing something fundamental about the universe.
Wow, okay, I need a minute to process all of this.
Take your time.
We've gone from sunflowers to bees to human bodies to famous works of art.
It's a whirlwind tour of the golden ratio.
It is. But I have a feeling we're not done yet.
Oh, you have no idea. Ready for the grand finale.
Oh, believe me, I'm ready. Lay it on me.
All right, but brace yourself.
Okay.
Because we're going cosmic.
Cosmic. Like outer space cosmic.
You got it. We've seen how the golden ratio plays out on Earth.
Yeah, from tiny seeds to the human body.
But its influence extends far beyond our planet.
Seriously. I mean, I knew this ratio was cool, but
It's more than cool. It's
yeah.
practically universal.
Okay, now you have to tell me more.
All right, so remember those logarithmic spirals we talked about?
Vaguely, remind me.
The ones that aren't quite golden spirals, but still create those continuous curves?
Right, like the Nautilus shell.
Exactly. Well, those spirals, they show up in some pretty amazing places out there in the cosmos.
Like where? Come on, don't leave me hanging.
Okay, picture this.
I'm
Picture
picturing
the swirling arms of a spiral galaxy.
like our own Milky Way.
Yes. They often follow a logarithmic spiral pattern.
Wait a minute, so you're telling me
Mm-hmm.
the same math that makes a sunflower seed head
Yeah.
also shapes entire galaxies?
It's mind-blowing, right? It suggests some kind of deep connection, some underlying principle,
It's like the universe has a favorite design
and it uses it over and over again.
on scales I can't even comprehend.
From the microscopic to the astronomical.
My brain is officially fried.
I told you to brace yourself.
You weren't kidding. We started with sunflowers, and now we're talking about galaxies.
It's been quite a journey, hasn't it?
It has. But I have one last burning question.
Shoot.
Why? Why this ratio? Why is the golden ratio so special? Is it just a coincidence?
That's the million-dollar question, isn't it?
Yeah.
Well, we don't have a definitive answer.
Typical. Come on, give me something.
All right. There are some theories.
All your
Some scientists believe it's all about efficiency.
deficiency.
Yes. Structures based on the golden ratio,
Yeah.
they might be inherently more stable, more resilient.
That would make sense for things like,
Sunflowers.
yeah, sunflower,
Sun cones.
vine cones, even hurricanes.
Exactly. They have to withstand some pretty intense forces.
Right, so the golden ratio could give them an edge.
Precisely. But there's another school of thought.
Ooh.
What's that?
It's all about aesthetics.
Aesthetics, like it just looks good.
Well, there's something inherently pleasing to the human eye about proportions that align with the golden ratio.
Okay, I'll buy that. Those spirals are pretty mesmerizing.
Right. And think about all the art and architecture that intentionally uses this ratio.
Yeah, they're striving for that sense of balance and beauty.
So maybe it's a combination of both.
Efficiency and beauty. A winning combo.
Nature seems to think so. I'm convinced. But who knows? Maybe there's something even deeper going on that we haven't even thought of.
That's the beauty of it, isn't it? There's always more to discover.
I think we've just scratched the surface today.
We have, but hopefully we've inspired our listeners to keep exploring.
To look for those golden ratios hidden all around us.
In nature, in art, in the very fabric of the universe.
And maybe, just maybe, one of our listeners will be the one to unlock the true secrets of the golden ratio.
I'd love to see that.
Me too. But until then, we'll just have to keep marveling at its beauty and its mystery.
And its power.
Well said. Thanks for joining us on this incredible deep dive, everyone. We'll see you next time.
Until then, happy exploring.